So let's see how we can solve this problem. Right away you can see that there are probably two main ways in which you can go about it, but you know what, let's do it both ways just in case you might not remember the product rule. So the first way we're going to do it is using the expansion instead of the product rule. Okay, so let's see here. If you decide to do expansion, the first thing that we have to do is to go about expanding this product here, and that should be your algebra. It should not be that difficult for you to do. Okay, so if you have some problem expanding, just know that here we see a difference of squares, and you should know, right, that if you want to quickly expand a difference of squares, so if you have some product, let's say that you call maybe y equal to a plus b times a minus b, that should always be expanded, and is going to end up being a difference of squares. A square minus b square. Okay, it works both ways. So if you see a difference of squares, you can always factor it as what you see over here. But for now, we only need to expand that part there. Okay, so y in reality is, for the first two factors of that expression, is going to be equal to x squared minus 1. Then it will be multiplied by x plus 5. Now we need to expand that expression. Let's see what we can do about that. There is not much we do not notice any patterns right away, so let's go for it. X squared times x cubed, x squared plus 5, the sign is going to be positive, so plus, the coefficient is 5, and x squared. Now we expand our -1 and the second whole factor. Two terms are going to come out of that, and they both will be negative. So -1 times x is -x, and -1 times +5 is going to be -5. There we are. So we have the expansion of y, and it should be a little bit easier to deal with that. Now, before we start dealing with it, we have to deal with each one of the terms, and these are all polynomial terms, so they should not be that difficult to deal with. And when you have a term, let's say that you have let me go to the next one, because this one is going to be the power rule, right, for a polynomial term. For polynomial terms. Okay, so in this case we might have something, a general term might be something like this. T in general, it will have a coefficient, maybe c, then the variable x, y, z. We almost always choose x, and then the exponent, and in this case let's choose e. Okay, so the term is equal to the coefficient times x elevated to the e for the exponent. And what we do in order to take the derivative of that term is that we say t prime for the derivative is going to be equal to, the e will go down and will multiply by the c, so we will have c ec, my apologies, ce times x to the e minus 1, and that is the constant one, right, minus an actual one. So there you have it. When you want the the derivative of a polynomial term. Most of the time you can get away with simply saying that t prime is equal to CE, meaning the coefficient times the exponent times x to the exponent and subtracted 1. A good little thing for you to memorize. So there you have it. Okay, we will be using that 4 times because we have four terms in this expression here. Okay, so let's see how we go about doing it with each one of them. Okay, so we have now we have that y prime is going to be equal to the derivative of the first term. So we need to take the derivative of x cubed, let's express it like that, and then the derivative of 5x squared, and then the derivative of, and you could say that is plus negative x prime, and the derivative of a constant, which in this case is negative 5. Let's see if I can put this a little bit here, and then negative 5. Now, a quick hint here: any constant, like this integer that we have here, any constant, the derivative of any constant, it will always be 0. The derivative of a constant is 0. Do not forget that. So you should already know that if you have a constant for constant k, let's say here for a constant, say k, okay, the derivative of k, the derivative of the derivative with respect to x or any variable of k is always going to be 0. Don't forget that. The derivative of a constant is 0. K could be anything, right? As long as it's constant, negative 50, negative 37, 51.32, 3.14. And remember that pi or e, those are also constants. So the derivative of those constants are also 0 because they are just numbers. Okay? So we know that this guy is going to go away right away. So in reality, your derivative is going to end up with only 3 terms in this case. Now, let's go back and quickly review the power rule. For every term that you have, what you're going to do is to multiply the coefficient times the exponent, then write your variable, and then take the exponent and subtract minus 1. Do not forget to subtract minus 1. Do not forget to subtract minus 1. Most students generally will forget to do that, and well, you will get it wrong. So don't forget to subtract minus 1. Let's see what we can do here. So for the first one, we're going to take the derivative of that. Let's see what we can do. It's going to be equal to, now one more thing before we take the derivative. You might say, what is at the front of the x? Well, you should know that there is a positive one at the front of the x. That is the coefficient of x, and the exponent is positive 3. So let's see how that goes. So it's going to be the coefficient 1 times the exponent 3, and this is that whole term, times x to the 3 minus 1. I'm going to write it the first time. Then the second term is going to be this one here, And we are going to assume that it's going to be positive. And the reason why it's going to be positive is because both the coefficient and the exponent are positive. So plus is positive, the coefficient 5 times the exponent 2 times x to the 2 minus 1. Then for the last one, let's see if I have another color here. We are going to check quickly to determine the sign first. The coefficient is -1, that is a 1 right there, and the exponent is going to be also 1. You already know from your algebra that all variables that do not show the exponent and implicitly is known that they are 1. So this is going to be plus -1, which is the coefficient, times 1, the exponent, x to the 1 minus 0. Are we clear about that? Hopefully that is clear to you. Okay, so then we need to just simplify these expressions here. Let's see. And this is going to be 1 times 3 is 3, x to the 3 minus 1 is 2, plus, so we are done with that guy there. Let's go to this one. 5 times 2 is 10. And at this point, it's a good idea, since that term is simplified, that you look at the expressions that could be or could not be. So we know that in this case, if we have a 3x squared, it cannot possibly be this one, and it cannot be that one, and it cannot be that one. And look at that, it cannot be that one either. There is only one that is available, right? So probably is going to be that one expression C, correct? So you do not have to continue with the problem and just mark your answer. Every time you get a term, you might want to check. It might not be in the test, it might not be as simple as this one, but please, every time you get to the line or to the part in which you believe you are cleaning up the whole solution, all of your writing, all of your operations, then check one term at a time to see if you find them and be able to eliminate some of those. Let's finish this, okay? So 10x, and let me change my colors here. So 10x to the 2 minus 1, which is equal to 1. We do not write the 1, so we leave it like that, right? So 10x. And finally, for the last one is going to be -1 times 1. The result of the coefficient is going to be negative. So -1 and x to the 1 minus 0 to the 1 minus my apologies, this one should have been, let's see here, 1 minus 1, correct? I jumped the gun a little bit there. So 1 minus 1 there. Okay, then for that one we have the -1 times 1 from here is -1. Then x to the 1 minus 1, that would be 0, x to the 0. And you already know from your algebra that any expression elevated, well, not any expression, okay? So if you have an expression, and this is just a quick review here, if you have an expression that is not, let me express it with an E, an expression that is not equal to 0, and that expression is elevated to the 0, it will always be 1. Are we clear? Don't forget that one. Please do not forget that one. So if you have an expression elevated to the 0, and assuming that E is not equal to 0, it can be anything but 0, or can be anything that does not end up being 0, then that expression is equal to 1. What did I say before? Did I say 1? Let me make sure. Yep, I did. So, but my students quite often make the same mistake over and over again. So There you go. Let me make this big and give you some animation here, maybe that will stick in your head. And here we are. So assuming that e is not equal, the expression does not end up being 0, okay, then e to the 0 is going to be 1. What an ugly one that is. Let me see here if I can get a better looking 1. And let's see here. I think I already did that. Uh-oh. There we go. Okay. So I'm trying to keep them all the same size. So let me see here, to make them bold, make them small, keep them again, and then make them big. There we are. Okay, so e to the 0 is 1, assuming that e is not equal to 0. Let's go back. Okay, so we know now that after we clean that expression, the 3x squared is going to stay the same. Then we will have our plus 10x, nothing to do about that. And finally, the minus 1. Remember that the negative 5 was eliminated pretty much from the beginning, because the derivative of a constant is 0. Do not forget that, okay? So just keep that in mind, okay? The derivative of a constant is 0. Okay, and you can see there that the result that we got is exactly the same as that one. Okay, very well. So now let's do this by the power rule. I think it would be good for you to do so. If you do it by the power rule, then after we do it with the power rule, we will discuss when to use one technique or the other technique, right? So we'll see. Let's go back. Before that, I need to take maybe a copy of this part here and copy that, and let's go down. Let's paste it and place it inside a nice place and delete all of the stuff that we do not need. Very well. Now in this case, since we are going to use the power rule, and it's more general, but it's a little bit more difficult to remember, but in many situations we're going to use the product rule. My apologies, not power rule. And this is for derivatives. So we need to talk a little bit about how to use the product rule. When you use the product rule, in short, basically is the following. If you have a term, whatever that term, not a term, but an expression, and there are several expressions multiplying each other. So let's say that we have y equal to expression a, and remember, all of these expressions could be in terms of variables. They are just, well, expressions. So I do not want to let me use maybe u, v, and w. So those are expressions where u, for example, could be something like x squared plus 2. V could be x plus 1, and a w could be something like 3 minus x cubed. So they could be expressions, all of them, assuming that they could be that, okay? But it's not necessary. Just take it from the point of view that they are expressions. Just take it from that point of view. So when you have something like this, it's a good idea to use then the product rule. And what the product rule says is that the derivative is going to be equal to Some people start at the beginning by taking the derivative of the first term and then multiply it by all the terms. So if you have three terms, you will get, if you have three factors, here we have three factors. So you will have, at the end, with the result, three terms. Let's see what those three terms are going to be. So I can start with the first one and saying that u prime times vw plus u v prime w, that's one way to see it, plus u v w prime, that's one way to see it. So the same thing you could say, since the product is commutative, you already know this. Some people prefer to kind of, how to say it, to put the derivative at the front or to put it at the end. I personally prefer to put the derivative of the term at the end because I want to first do the easy parts. So when I do this, what I do is that I say, I can start from the end and say uv times the derivative of the n, which is w prime, plus, then I move to the next one, which is v, and I say uw, I do not need to do anything to that one, but v now is going to be the derivative. And finally, I take v and w, and then I take the derivative of u at the end. You can do it that way. And also, you can do it like this. v w u prime plus then uw v prime plus and then vw, right? No, uv times w prime. So that is another way to do it. And I think anywhere you decide to do it, the results should be the same. So which of all of these do I prefer? As I told you, is the last one, and that would be the product rule. So when you have something like this, and to express it cleanly, let's see what we can do here. Product rule for an expression similar to this. Okay, maybe the next line, we have plenty of space, is going to be, I think I can take advantage of the last one here and copy that, go next, paste it here, and it's just needing the y prime is here, and y prime is going to be equal to that. So we're going to take everything, make it red because it's important, and make it big. There we go. Okay, so product rule for y equal to u v w would be something like that. Now that could apply to also two terms. When it's two terms, it's even easier, because let's say that is two terms and you do not have the w. Then when you do not have the w, you could think of the w maybe as 1, okay? If it's not there, and the derivative of 1, what is the derivative of a constant? 0. So that whole expression here will simply go away if one of them is 0. So you can use the same power rule for not only 2 or 3, 4 or 5. You just will have to continue to do the same, to continue with the same pattern over and over and over, right? So let's go back and let's use the product rule to do this one. Okay, so if we use the product rule, it should not be that difficult. Then we have that I'm going to start over here. Y prime is going to be the second and the third. I'm going to leave like that, x minus 1 times x plus 5 multiply by the derivative of the first one. But what is the derivative of the first one? It's simply, if you look at it, it's simply going to be 1, because the derivative of x plus 1 is 1. Remember that the 1 is going to go to 0, and the x is going to be equal to 1 if you apply the power rule to x. Then the second term is going to be equal to the first and the third term, x plus 1, right? Times x plus 5 times the derivative of the second term, which is this one here. And the derivative of that is also going to be 1, because the derivative of negative 1 is a constant, is 0, and the derivative of x again is 1. So there you go. And finally, plus the last two terms, that in this case is going to be equal to x minus 1 and x plus 5. And then the derivative of the first term. My apologies, let me see here. I think we already did the first term, so we need to do the first and the second, right? Yeah, I am wrong completely. So we need to do now the first and the second. Let's see here. So we are in the last term, x plus 5. So it's going to be x plus 1 times x minus 1 times the derivative of the last term, right? Which is going to be, the derivative of 5 is 0, the derivative of x is 1. So easy enough. So I just need to expand all of this in order to find out what is going to be the final expression. Now, if I expand this, let's see how it goes. And I think you do remember from your algebra that when you have something similar, an equation or an expression like y equal to, and let's take a look at those expressions. Look how the x is there, followed by a term that is a constant. So we can generalize it by saying that x plus a, since they kind of occur quite often, x plus b. When we have something like that, is going to be x squared. Then x is going to multiply by b, and then, so you do the x plus a, and then this one, and then you will multiply, my apologies, not that, x times x, and then x times b. That will get you two terms, but then you do b, you do in the States they have a way to do it, right? That they tell you the outer ones, the inner ones, and so on and so on. But to me, is kind of like a second nature already. So I know that, let's see here, when after you expand those two, then you need to expand this one times that one, and that one times this one, correct? But you will get also what? After you expand that, you will have, and let's put it together on this, x squared bx plus ax plus a times b. And these two are like terms because because bx plus ax just collect. So most of the time the way we write it obviously is a plus b x, a plus b x. There we are. And then you put ab, the product of a times b. If one of them is negative, keep that in mind. You need to keep that in mind if either a or b is negative. Since it occurs so often, it's a good idea for you to keep it in mind. Let's go back and see what we can do about this. So for the first one there, it's going to be x squared and negative 1 plus 5, what is going to give you? Positive 4x, and then negative 1 times 5 is going to be equal to negative 5. Then you will get plus. Now I'm doing the second one here. Okay, then we will get x squared, then 1 plus 5 plus 6x, and then 1 times 5 is positive 5. There we are. And finally, the last one, which is this one, we will get again our x squared, and then 1 minus 1 is 0, so no x's, right? And that is the difference of squares. Again, if you look at it right away, that is at the difference of a square. Since all of them are multiplied by 1, right? They are all multiplied by 1, so we do not have to worry about that factor in the outside. So x squared minus 1. There we are. Now, this is going to be equal to in the final answer. Let's see if we can just look at it from here. I can see that all of these are going to be 3x's by collecting like terms, correct? And right there, you will see that 3x squared is only in C. We know it's not that one. It's not going to be that one, nor this one, nor that one. So again, same result. Then let's complete the rest. If you look at these two, right, that is going to be plus 10x's. And then if you look at the final part here, the 5 together with the negative 1, right? These two will cancel each other. Negative 5 plus positive 5 will cancel each other, and you will be left with the negative 1. Are we clear about that? Let's see if we, yep, it's exactly the same result. So, which method you prefer to use is up to you. In this case, what would I have done? In this case, since the exponents and the terms in this part here are simple enough, they are just binomial, the best way to go about it is using expansion, right? I think that in this case, expansion is the way to go. Look at the expressions that we got, and the number of terms, the amount of work that we have to do in order to get to it, and look at the work that we have to do here. Not too bad, right? But still, I think that for this specific problem, expanding it might work. So it's something that you simply get with experience, when to use the power rule and when to use expansion. It's always good to use expansion. It's always good to know the product rule, because it can simplify certain other type of problems. Expansion is easier to remember. You just do it more mechanically, but you should not forget about doing it by using the product rule, please. So yes, because most of the time, and another clue is, if you look at the answers here, all of the answers, if you look at them, are already expanded. So that kind of gives you a clue. If the answers are expanded, then you might want to actually use expansion, as long as they do not give you too many terms. In this case, they only gave you 3 terms, and they are fairly simple. 3 terms, and they are fairly simple. They are just binomials, power 1, of degree 1. That's what those polynomials are. Each one of the factors in there is a polynomial, is a binomial of degree 1. So in this case, yes, it's good to do it. It's a good way to go. But if you have 5 terms, or they are not exactly of degree 1, things can get a little bit messy, and quite often they will give you the answer not expanded. In another word, they will give you, the answers that they will give you is probably this is going to be this part, let's see here if I can find all of them. Yes, the answer that they're going to give you is that part there. So they will tell you that is equal to x minus 1 times x plus 5 plus x plus 1 times x plus 5 plus x plus 1 times x minus 1. They will just give you that part without factoring. You will have to figure out that they are basically indicating to you that is the power rule, what they are using in that case. Okay, hopefully that helps you. And don't forget, let's see here, I think that covers everything for now. I will see you if you leave any comments, if you have any questions, criticism, that they are always welcome. Just don't be too rude. You can go ahead and yeah, be rude. Some people just love that. I know how to take it, but try to be constructive. There's other people who is watching this and trying to learn. So if you have constructive criticism, please go for it. And then next time I will continue with another of those CLEP calculus problems, and we'll see how it goes. Okay, very well. You guys take care. Bye bye.